welcome back. Let us look at another example where we have to solve for the triangle, whether it's the missing sides or missing angles. Guys, in this example, we have a triangle ABC, and the three angles of the triangle are provided to us, but we don't know any of the sides. So our goal is to find the sides here. So guys, in order to find the missing angles or the missing sides, the very first thing that we like to do is we like to set up the sine law. So let us go ahead and set up the sine law and see whether we can use the sine law, whether the sine law helps us to actually evaluate or find the missing sides. So let us go ahead and set it up. So there's two ways of writing the sine law. So guys, let me start with writing the sine of A over A. That's one of the ways, which is going to be equal to sine B over B. Let's see. We have sine B over B here, and then guys, the third ratio is sine C over C. Now let us substitute the values. We have sine of 50 degrees over the length A is not known, and then I have sine of B, which is sine of 100. Again, my B is not known, length B is not known. Then sine of C, we have the sine of the angle C, which is 30 degrees, but we don't know the length of the side C. So looking at these three ratios, and if we take any two at a time, first two or second two or first and the third one, guys, again, we are going to be stuck in that problem where we have one single equation. Let us, for example, focus on these two ratios. So we have B and C, there's two unknowns and it's just one equation. So if we cross multiply whatever, like the method that we use to solve when we have rational equations or rational functions, guys, we are going to get stuck because we have only one equation and two variables. So we cannot solve for two variables just using one equation, right? Same thing, guys, if we just combine, or if we just look at these two, first ratio and the second ratio, again, two variables, one single equation. We can try to cross multiply, but we won't be able to solve for two variables given one single equation, okay? We can only solve for two variables if we have two simultaneous equations. Then we could solve it, but we don't have something like that. It's just one equation and two variables. So what does that mean? That means sine law cannot help us to solve this particular triangle. So if sine law cannot help us, then one has to try and see if the cosine law may help us. So guys, the second option for us is to set up the cosine law. So this does not work, forget about it. Now let us try to use the cosine law. Again, with the cosine law, let us start with, there's three forms. Let us start with any one. Let us start with a square equals to b square plus c square minus 2bc cosine of angle is going to be a. It's always the included angle between the side B and C. So the included angle between the side B and C is a. Okay. Now let us substitute the values and see how far we can get from here. Guys, we don't know a square, we don't know b square, we don't know c square. So we don't know it because we don't know the values for the lengths a, b and c. All we know is the cosine of the angle. So we can say cosine of 50. So we have one equation, just one equation, and how many variables? Three variables, right? A, b and c. There's no way that we can solve for three variables just by using just one equation where we have three missing variables, right? So there's no way we can solve for A, B, or C just by using this one equation. Same thing, guys, if I write the other one in terms of B square and C square, we're going to get stuck with the same situation, same issue, that just one equation and there's too many variables to solve for. So that means there's neither the sine law helps us to solve this, or the cosine law does not help us either, right? So this is a case where we cannot actually solve for a triangle. We may be able to solve for these triangles, but at this level, guys, with the tools and with the concepts and with the things that we know, we won't be able to actually solve for this particular triangle. So this is a special triangle, which you can also think of that as AAA triangle, where the three angles are provided. So whenever we have an AAA triangle where three angles are provided and all the three sides are missing, we cannot figure out, we cannot solve the triangle. We can't solve this triangle. So guys, I want to finally conclude this section on solving for triangles, especially these oblique triangles with these different cases that I have already done in my videos. But I just want to conclude this. So guys, there is the first one. If I have SSS, three sides are provided. So I did that in my previous example. Then you have to use the cosine law. That is the law that works for SSS. Then guys, if I have an ASA triangle, So two angles and this side, then you have to use the sine law. And then guys, I have done all these examples with all these different types. Then guys, if I have two angles and a side, AAS triangle, and I'm expecting that you have already gone through the rigorous like a geometry course, so you understand what does this SSS and ASS and AAS all mean. Guys, if you don't, then please go back and review some basic things from your geometry class. Again, sine law works. So sometimes both sine law and cosine law may work, but guys, sine law is easier to use, so you should use the sine law first. Then guys, we talked about the SAS as well. This is the one where sine law did not work, so we have to use the cosine law. And then the fifth one was SSA, and the sine law works for this one. And the last one, if we have three angles AAA, then guys, it can't be solved. Cannot be solved. So guys, you can make a note of this, or if you don't want to make really you don't want to remember it like that, then one should start trying with the sine law, and if you cannot solve it with the sine law, then just move on to the cosine law. It's as simple as that. Okay guys, this brings us to the end of this solving oblique triangles. I will see you next time with some other concepts. Till then, take care. If you have any questions, feel free to reach out to me. I will see you next time.